Hello everyone, welcome back to Advent of Code 2023. We're going to be doing day 13 today, but as often in this series, I wanted to review a few changes that I made to day 12 before we get going, in between the last video and this one. I don't remember if I did this one on camera or not. I think I did. I just changed the, I had written pure of a dot when, like, there's already a way to do that. you just write it as a string. So I think that was already done on camera, but just in case, here it is. This one is a little bit more lengthy, but it's actually really simple. I just, I said I want to use the efficient... I started working on optimizing just to see, like, you know, how much faster it could easily make it. Even though speed wasn't an issue, it seemed like it would be nice to see, like, how much I could improve what I was doing. So part one was this thing of just, like, literally iterate, try every possibility and see which ones of them give the right label. It was fun to write, and I knew, you know, when I wrote it that it would be slow, but it was going to be a good example for anyone watching. But I don't mind removing it from the repo. You know, it's in the history if you want to dig it out, of course. But I decided to use the fast part 2 solution for part 1. That already sped the program up from, like, 4 seconds, I think it was, to 4/10 of a second. So it turns out, actually, most of the time in my solution was being spent in part 1, even though it's a much simpler problem, because part 2 is just that much more... My solution to part 2 is that much more efficient than my solution to part 1, so haha. And I think all I did was I took the entire implementation of part 2 and moved it to a top-level function called possibilities, which they were both using anyway. Right. The function named possibilities they were both using, I deleted the one that part 1 was using and lifted the one part 2 was using. And then I made unfold a function private to part 2. And that's the only change. Oh, right. And you don't need group anymore because that was only used by my part 1 solution. And then lastly, I made one more little change. I complained about how much harder it is to use arrays than maps because I can never remember the API, and it's like, I don't know, every time I do it, it gets a little bit less confusing. This time it was not too bad. I switched from using a map to using an array to see how much more efficient it would be. And it was 4 times faster, I think. It was taking 4/10 of a second, and now it takes 1/10 of a second. So we just have to depend on array, and instead of maps, we import the module for lazy arrays, or immutable arrays, I should say. When you have to mutate arrays, it gets more complicated, but I'm not doing that today. We're building it all at once, remember. So I just replaced all the references to M with A, and then I had to change how subproblems is defined, right? Everywhere else is just calling a different indexing operator on subproblems. Here, subproblems is very similar, but instead of just calling from list and giving it a list of pairs, you have to give it the bounds and then also a list of pairs. One of the things that took me the longest here was the latest version of data array actually contains a function that would make it easier instead of harder to build an array from a list like this. Instead of, like right now, okay, to build a map, you give it the keys, or a list, anyway, using from list to build a map. You give it a list of key value pairs and it puts those in a map for you. Very reasonable. How could you do better? Well, the answer is an array knows it's a grid, and it knows that your index values have can be mapped to and from int, basically. And so there's a function in data array, the latest version, which is, instead of array, it's gen array, I think, like generate. And you just tell it the bounds, and you give it a function which takes in bounds and puts out the value. So I could have just passed, like, uncurry subproblem. You could write, like, a.genArray these bounds $uncurry subproblem, and that would be the entire definition of subproblems. Except you'd have, I mean, H and W. Yeah, I guess those would still be in the where clause. But this whole loop over, the list from 0 to H and 0 to Y and redefining the bounds would all be gone, because gen_array just says, oh, well, I know your min bound and your max bound. I'll compute all the keys for you. You tell me for each key what you want stored there. That's an easy function to write, and you could write it yourself. But you're not saving yourself much work if you do that, and then only call it once. So the issue is that the latest version of data array is on Hackage, but it's not on Stackage. And since I'm using Stack rather than Cabal, I don't think there's a way for me to get the latest version of data array. I await with bated breath when I don't understand how Stackage snapshots update. I don't know what the acceptance criteria are for getting the newest version on there. It's like 5.4.0.0 versus 5.6.0.0. So there's like two versions. I don't know. It's a mystery. Point is, that function isn't there. Wouldn't it be cool if it were? All right. Why did I went back to day 12 to say get log, but I could have done that in 13 as well. Anyway, on to day 13. And today I am going in blind. Some days I do this, some days I look at it ahead of time, and today I haven't. So I have no idea what day 13 will be about. Let's find out. Day 13, point of incidence. With your help, the Hot Springs team locates an appropriate spring which launches you neatly and precisely up to the edge of Lava Island. There's just one problem. You don't see any lava. You do see a lot of ash and igneous rock, and there are even what look like gray mountains scattered around. After a while, you make your way to a nearby cluster of mountains, only to discover that the valley between them is completely full of large mirrors. Mirrors, huh? It was supposed to be... what do you call it when, like, you focus the light from something on something else? I mean, I don't know. It's... I think that's kind of what we're talking about here. When you, like, use a magnifying glass to pop a balloon or whatever, using the heat from the sun, I guess they were probably using that to heat the rocks into lava? As you move through the Valley of Mirrors, you find that several of them have fallen from the large metal frames, keeping them in place. The mirrors are extremely flat and shiny, and many of the fallen mirrors have lodged into the ash at strange angles. Because the terrain's all one color, it's hard to tell where it's safe to walk or where you're about to run into a mirror. You note down the patterns of ash and rocks. There sure are a lot of these 2D grids this year that you see as you walk, your puzzle input. Perhaps by carefully analyzing these patterns, you can figure out where the mirrors are. Oh, we're just going to figure out how to walk around the mirrors. We're not going to use them to heat up the volcanoes or something? Okay. To find the reflections in each pattern, you need to find a perfect reflection across either a horizontal line between two rows or across a vertical line between two columns. Sure. So, is this one input with like two subproblems in it or something? Patterns of ash and rocks. Okay, so I guess this is a pattern. This is a pattern. In the first pattern, the reflection is across a vertical line between two columns. Arrows on each of the two columns point at the line between two columns. Sure. In this pattern, the line of reflections is the vertical line between columns 5 and 6. Because the vertical line is not perfectly in the middle of the problem, part of the pattern, column 1, has nowhere to reflect onto and can be ignored. Every other column has a reflected column within the pattern and must match exactly. Second pattern reflects across a horizontal line instead. Row 1 would reflect with a hypothetical row 8, but that's not there, so it doesn't need to match anything. To summarize your pattern notes, add up the number of columns to the left of each vertical line. Also add 100 multiplied by the number of rows above each horizontal line. Now, I feel like, I mean, I understand what they want, but I don't think they said it explicitly enough. Because, of course, given the, like, oh, if it doesn't match the whole input, you can, like, if it's not perfectly in the center, you ignore the bits that don't overlap. That means there are two other solutions to this puzzle, right? The line over here after column 9, which is empty on the right and has the whole thing on the left, and we ignore the whole thing. That's a perfect reflection, right? Likewise, left of 1, a line here would have nothing on its left, and the whole pattern on its right would be ignored. But okay, I guess they are just assuming, implying that you should not take such degenerate rows and columns reflections. Add the number of columns to the left. Yeah, okay. So, this kind of reminds me of... Let me go look at my 2021 solutions. Because I remember... How do I search? I'm logged in. I should be allowed to search. You used to be able to... Yeah, I don't need to download it. Here? No. What? I thought you could just search on... There's a search bar that's supposed to be right here. Or here? I want to search for when I used lens, because I remember I used a lens function to flip things. I mean, I could clone this, I guess. But it's not what I wanted to do. Okay, fine. Let's do it. Here we go. I already have it. It's in the same... Okay. I thought I had used a different, virtual machine or something for this. So, if I find a Haskell file, grep for data... No, what is it called? Control lens? Might be data lens. I don't know. It is control lens. Day 13. So if we were to go back to Emacs, this was something about reflecting stuff, I remember. Wait, also, isn't today day 13? No, it's day 13 today. So, yeah, template Haskell, control lens, make lenses, no. We had an axis. We were given, a set of points on a paper, and then told, some set of folds to apply to that paper. Or unfolds? I don't remember exactly how it worked. Yeah, fold along. So we read the dots. So I guess you were told like how to fold up the paper, and then you put dots in the folded up paper, like by piercing them with a pin or something. And then you say how many holes are now in the unfolded paper, basically, as I recall. And then part 2 was like, okay, cool. Actually, the folds that we gave you were instructions for. Oh, actually, I think I can look at my input, right? Yeah, there were zillions of points given to us as input. But then you fold them up, and they like formed a string, an image. We can actually, I think, probably just day 13 stack run, right? Just for fun, to see what this looked like. I don't know. Oh God, it's like got a different. It wants different snapshots or something, or this is the first thing depending on lens. I don't know. All right, it's going to take a while, and it's not clear that this is helping at all with this year's problems. I just thought it was interesting that like this is another example of folding stuff, and I remembered, oh yeah, what did I do last time? There was all this folding going on, or reflecting. Okay. Well, I don't think there's that much to do here. Let's just close that. I don't need this either. Okay. So here's day 13. So let's go revisit the problem statement again. Above and to the left. Oh, there was something else I meant to say about day 12 actually. The other obvious thing to improve here would be string is a famously inefficient data type, right? A linked list of characters is a bad way to represent text for most of the ways that text is used in programs, right? You treat it as opaque most of the time, and sometimes you want like random access to elements or something like that. You don't need it to be lazy. There's all kinds of reasons string is not a great data type. It's fine for small programs like Advent of Code, or stuff that doesn't have to be efficient, which is like pretty much everything I ever write. But I thought, hey, since I'm going for efficiency, maybe today would be a good time to learn to use text instead, which uses like an array of UTF-8 encoded bytes. But I was kind of disappointed when I looked through the API of text. That like a bunch of operations that seem like they should be fast are actually O of n, right? They take linear time because the array is UTF-8 encoded. And so if you say, what's the second character in the string? It says, hang on, I have to UTF-8 decode the bytes I have to figure out whether the first character is 1 byte long or 2 bytes long or 3 bytes long or whatever. And so all these operations that I thought the whole point of text was that operations like this could be fast, they're not. So I just didn't make any effort at all to switch to text, and now I never will in my whole life. Okay. So right, we was revisiting the problem input. It wants the number of columns to the left of each line and number of rows above each horizontal line. So that's actually kind of the same problem. We definitely do not have to write like a vertical line finder and a horizontal line finder. We'll just write one of them, and we'll use transpose to reorient the input to be viewed from the other angle and then just use the same solver on it. In fact, like, maybe that would be interesting. What if we take this, just to show you, like, what I mean. Like, if you don't know what transpose is, I don't know. I mean, I guess that could happen. Input.text. We'll write this here, even though it's not our real input. Yeah. No. That's one thing about IDO mode, is that if you want to find a file that doesn't exist, it like tries to autocomplete you to something else. So here's like, God, did I paste it twice? I did. That dang old right mouse button is so janky. Okay. So if we now go and say let input equal lines of read file input.text. Oh, that's not what I wanted to do. I want to say input comes from this. That's fine. Now if I say what is the input, it's this. Traverse put sterlen of input. There. Oh, come on, import. Where's traverse underscore? Data foldable? Yes. There you go. So that's our input, right? Traverse put sterlen of input. And if I say traverse put sterlen transpose of input, import data list transpose. We've now kind of rotated our input by 90 degrees. If you look, for example, at the first column here, starting from the top and going downwards, you'll notice it's exactly the first row of this, starting from the left and going rightwards. And then the second row here is the second column here, and so on. So transpose inverts the meaning of row and column for a list, basically. A list of lists. So as long as we just call transpose, we only need to write a solver for one of the two things. And given that what we have is a list of lists, it's going to be way, way easier to write a solver that goes from the top down. Because I can just, like, the rows are already objects. I can say, like, hey, you know, take 5 rows should equal reverse of drop 5 rows, or not equal, but should zip with equal. I think that makes sense. Yeah. Because that way, if there's anything that doesn't match between the two of them, it'll just be ignored, which is perfect. Okay, yeah, that makes sense to me. So I think we're about ready to start. Out of curiosity, what? Why didn't it? I said stack run, didn't I? Shouldn't you have done something? Oh, it's. This was back when I thought I should. No? I'm sure my day 13 solution worked. Something's broken about it. This is back at the 2021 solution now. It finally finished building, so what was wrong here? There were warnings. What the heck? How on earth am I matching on stuff from dataset internal? This doesn't look right. Oh, maybe there's a view pattern of some kind? Line 28 of day 13. I gotta check this out. What's my input? It's a list of folds. How is there... what? You're telling me line 28 is a non-exhaustive pattern in function part 1. And if we look at the output of build, the only non-exhaustive pattern warning we got was here. In an equation for part 1, this you're saying I'm not matching a tip and... Oh, okay. I see. These are things that I'm not supposed to know about. They're just different internal things. But P covers both of them. The point is that this doesn't cover an empty list. So, I don't know. Something has bit rotted in my implementation. Forget it. I'm out of here. I could swear it worked. We're in day 13 now, right? Yes. Okay. Of this year. So maybe... maybe we'll just define a useful function first. Axis of symmetry takes a... Given that A is equable, can be compared for equality, it takes a list of A and returns an int. I don't know, like an int is a lie, right? Obviously it can only return a maybe int, and we're just going to assume that there's always a match. I guess I should write maybe int. So axis of symmetry is... I want to, like, split the lit at a certain element, right? I guess it's like the head of... Let's just write do here. I'll figure it out later if that makes any sense. I from 1 to infinity. Let before equal x's y's equal split at I. Oh, all right. X's. Split at I x's. Do I want like when or pure or something like that? I don't know. I guess I'm supposed to use guard. If I used list comprehensions, this would all just come for free, but I just like can't think in list comprehension terms. I have to think in monad comprehension terms. Guard that x's guard that all id guard composed with all id? Does that make sense? I think it does. Zip with equal x's y's pure I? Does this make any sense to you, compiler? Almost. Oh, right. Well, okay, we'll just return an int. And then eventually it'll return true when it gets to the end of the list and finds that it can split the list into just the bottom, which is empty, and the top, which is the whole thing, and find that they zip correctly. So you know what? We can even try to protect against that, right? I can say, look, pull out X's and Y's, but these better both be non-empty. And so now we have a non-exhaustive pattern match, but that just means we'll get an error when things don't work. So that's sort of what I wanted. So let's do this again and call axis of symmetry on input. Exception! Great. Okay, good. Well, I'm happy about that, aren't I? We're supposed to reverse one of them. Still wrong. Okay. Why? I mean, split at. Let's go look up the docs for split at real quick, make sure it behaves the way I expect. X's is a prefix of length n, second is the remainder of the list. Yeah, that makes sense. Okay, that's what I thought. I kind of hate to use debug trace so early, but I feel like this is perfectly correct, what I've written here. Import debug trace. You have to be careful here, right? To make sure it's actually forced. Let's trace show I X's. So this should print I every time it calls split at, basically. Oh! This... I haven't parsed the input. I was thinking I still had my test input in the input.txt file, but I don't anymore. Okay, that's fine. I have to split the input into multiple problems. I wanted to, test on the test input, but that's fine. So let's write our little prepare function here. Our input is a list of string. Yes, correct. Let's go look at my input here. So they're separated by blank lines, and they're differently sized, huh? Okay. 20 composed with that, just to make sure there is an empty line in there somewhere. Yes, there is. There's surely something in data list that splits a list on separators, right? I don't know. I don't easily see one. What type would such a function have if it existed? It would have like eq a, take an a and a list of a and produce you a list of a? Okay, yeah. So there is all this stuff. Split list, split on, split. But none of these are actually in general purpose libraries. This is some utility that a number of larger programs have decided they want, but nobody's put it in like a reusable library. All right, well, we'll just use regex applicative, right? Does that make sense? It seems like it should be okay. I use it for everything else, right? I'll leave debug trace in there for now. I imagine this will work, and then I can forget about it. Import text regex, but just in case it doesn't work, wouldn't it be nice for this to print eyes? I don't know, it probably wouldn't. But just in case it's wrong, I don't want to take this out and then put it back in. So I'll leave the import in. Applicative, we want re match sim. Do I want a sim? I guess so. Oh, you know what? There's one thing I wanted to do. Let's just say I probably don't need these. I wanted to try out overloaded strings, because something I didn't realize until recently is that text regex applicative has an isString instance. So instead of writing like string of foo, I should just be able to write foo, and GHC will look at that string and the context it's being used in and say, oh, this string is supposed to be a regex applicative matcher, and we'll use its isString instance to convert it to a regex, you know, to call a string, basically. So, I mean, in that sense, maybe I don't need sim or string at all. I'll just try using the ones from the type class instance. But I do want some for repetition. Okay. And I guess I'll go back to my usual pattern of actually defining meaningful types instead of what I did yesterday, which was just work on the input characters as characters. So we have data feature again, I guess, is either ash or rocks. Those are the two things given to us in the problem statement. Deriving show eq ord. Do I need anything else? Maybe enum. Probably not, though. Why are you saying couldn't match type? Oh, because I haven't updated prepare yet. That's fine. So in fact, oh no. Well, now it would be a list of lists of feature, which is getting a bit of a mouthful. What are these called? We call these patterns? So I think our input is a list of pattern, and a pattern is a list of feature. That seems okay. So, I mean, we can write feature is a type parser of a. Parser of a is re char and a. A feature is a parser for features. Feature is ash. Which one's ash? The dot, right? Yes. Or rocks hash like so. Right? Ugh, I can't believe that's not automatically imported in the year 2023, but okay, fine. So this parser now compiles. You know what? Prepare is undefined. Like, give me a break, will you? I'll get to it. Now we're just getting warnings. So if I make a type error somewhere, it'll tell me. Yeah, and so look, the string instance, the isString instance worked. I could have written string this or sim and then a space, but using overloaded strings, I can just write out the text now. That's kind of nice. A pattern is some line. Is that true? I think so. You know what, let's just not define these as top-level functions, shall we? Let's just put them all inside of a single parser for input. Input is a parser for input. Input is something where okay. Pattern is some lines. A line is some feature followed by an ignored new line. And I believe we can just say that the input is... I'm going to have to write sep by, aren't I? Again. Sep by... You're allowed to define things in fix, right? P sep by sep is... I've written this a few times. I'm not going to explain it again today. Cons P and then... Oh, do I just need many? Ugh. Many sep and then a P, right? It's telling me about ambiguous types here, but I think once we're done writing input, inferences will flow back into feature and so on to tell me what type this is supposed to be. So I think it's fine. So input is just pattern sep by an extra new line, right? Like that? Yeah. So that matches just fine. And we can then say prepare, take head prepare. Let's just look at the first one. Read file of input.txt. Undefined. Oh, I didn't reload. That's why. Let's try again. Nope. Oh, prepare is not defined. Prepare is from maybe error no parse equal compose with matching input, where how about that? From maybe's got to be imported. Import data maybe from maybe. Okay. Yeah, so now it's just complaining about this pattern match here again. If I reload and try again, yeah. So this parses part 1. And we can then say, what is the axis of symmetry of that? Yeah, okay, it broke. Good. Sort of. We tried 1, 2, 3, 4, 5, 6, 7, 8, 9, and none of them were right, huh? And what exactly is the length of the list? 9. So I agree, once it got to 9, it should have blown up, because there was nothing left below it. But it shouldn't have gotten to 9, of course. So, what happened? Well, let's try axis of symmetry on a smaller input, shall we? Dot, 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 dot. You should really say the axis of symmetry is 1. It is 1. Okay. What if I put some hashes here in the middle? Then you should say the axis of symmetry is 2, right? No, you say 1 still. Oh, you know what? Fair enough. That's also a valid answer. Because if you split the list here... No, this is an invalid answer. Is something wrong with my reverse? Maybe I'm supposed to reverse the top and not the bottom? Does that actually matter somehow? It shouldn't. Something's wrong. Because when you split the list here, the first double dot should match up exactly with the first double hash, and those should compare as not equal, and it should say, nope, this wasn't right. Why would this happen? Well, I mean, it makes sense, I guess, with my implementation. When I reversed what was here, this matched up here, but that's wrong. You actually do have to reverse the first, not the second. How is that possible? I guess the point is, it does matter which one you reverse before comparing them, because they might not be the same length. When they are the same length, it works to reverse either one. But when they're different lengths, I see. Now, is it possible... that you have to reverse, like, whichever one is shorter? That doesn't seem right. Because this location here, what if we tried to put the axis of symmetry there? Oh, yeah, that would be another false answer, wouldn't it? If I just reversed the left one, or the top one, or whatever. Then I would compare the dot dot. Something's wrong with reversing. How can that be? It's so obviously correct. I guess the issue is you shouldn't reverse the entire bit here that you're comparing. You should take the section that matches, like that has a corresponding pair, a counterpart, and reverse only those lines, right? Because when you put the line here, this should match with this, and then that match should fail, obviously. And so what we should do is take the whole thing to the left, but trim any parts of it that don't have a counterpart, i.e. all this stuff. We should remove it and then reverse what remains. Okay. So I think what that means is we can just zip the two lists together. Which will give us a list equal to the shortest, or it'll give us two lists equal in length to the shorter of the two. Then I'll reverse one of them arbitrarily, since they're both the same length, and then I'll just say, is the result equal? Like, are those two lists equal? Okay, I think I now finally understand why that isn't working. So we don't really want this anymore. Instead, we want to uncurry equal. We're gonna be working with a tuple now of strings, and I just want those two strings to be equal. That's what uncurry equal will give me. We'll reverse the second one arbitrarily, which is what fmap will choose. Not choose, it's constrained to work that way for tuples. Zip x's y's. Is that all? No. Okay, give me a longer type error, please. Couldn't match. What? Okay, this is the second argument of dot, which is zip x's. You thought would have type list of A to pair of two lists of some other type. But actually, it has type list of A to list of pair of lists of A's? Well, yeah, I agree, that's stupid. Why does it have that type? All right, let's try and write it in a less clever way. So we've already split the list. Match or counterparts equal, well, I mean, a above and below to be zip x's with y's, I guess. Guard that above above equals reverse below? Okay, it's the same error, I think. I don't, why? What are, I mean, huh? Oh god, and I can't give these proper types because if I say they're of type A, it won't. All right, we're all A. There we go. Is scoped type variables implied by GHC 2021 rather? I hope so. This has type list of A is my belief. I've said split at I. Are these both list of A? I guess they are, right? Because we have a list of A and we're splitting it. We're like splitting the rows. Oh, wait a minute. Do I not even need? I don't think I need that it's a list of things. I'm never going to work a level below that because I'm just calling equal on it, right? Well, okay, what should the type of x's comma y's be? Maybe that's what I'm confused about. It should be list of A, right? Yes. It agrees with that, doesn't it? How can I be using zip wrong? It's the easiest function in the world. Guard is okay. Above is equal to reverse below. What? So we're not getting a type error on this line, or really on this one, right? No, we're getting an error only on this line. It's saying I have a list of pairs when I want a pair of lists. Oh. Yeah, I guess that's true, isn't it? Zip. I'm so used to using zip with, where I give it a function and it doesn't give me back the pairs anymore. It just like calls the function and gives me a list of the results. I guess, like, and of course this is just zip with, like, make it a tuple, but I was somehow confused and thought this would give me a list of a pair of lists. But obviously I gave it a pair of lists. Its whole job is giving back a list of pairs. Okay, great. So I think actually, A list of pairs is obviously what I want. And now the error should be here, right? On line 22? Still line 21. Ugh, sorry, I've had something in my throat for some time in this video. You can hear because I keep like, clearing my throat. Pattern above, below. I mean, this reverse, I guess. Oh, of course, I can't pattern match now. Counterparts. Guard that all uncurry equal of counterparts? Does that make sense? Yes. So counterparts is a list of the pairs. This is wrong, though, because now I'm not reversing either of the lists, which I do need to do. So I guess something's weird here. Uncurry equal of fmap doing something wrong here. Let's not be so fancy. Above is it's reverse map first of counterparts. Below is map second of counterparts. And now I can say all identity of zip width equal above and below. Yeah. Okay, so that still compiles, and I have more reason to believe it's true. Also, a nice fact, by switching from the list of A to just list of A, it's now impossible to accidentally reverse at the wrong level of nesting, right? I can't reverse the elements of a row because the type system doesn't allow me to assume that there is such a thing as elements of a row. There's just the list, and like I have to leave each item in the list alone. I can't touch it except to call equals on it. So what if I reloaded and tried this again? 2. Good. Now we're sort of in business, right? And this one should also be 2, right? No, it's broken. Why? Well, yeah, obviously this is wrong. I'm zipping this list here before reversing it with this list here. And so we get ... compared with this, and then I reverse this one element list, and it doesn't work. It says, oh yeah, that doesn't match with what's at the end. But I put the line here, which means I want you to look at this element as compared to this element. So was I actually supposed to zip with, or to zip them first? No, to reverse the first one first? I think so. Why? How did I convince myself I was supposed to not do it in that order? So of course this still compiles, but that doesn't give me any particular confidence that it'll be right. This makes sense to me. Now it says 2. Okay, and also, by the way, this tracing here is not useful anymore. We'll just get rid of that. Leave debug trace in. Maybe I want it later. I get warnings about it. Fine. Fuck you, compiler. And these are no longer needed. So I had written some... Now it says, oh, of course, the axis of symmetry is 1. So what if I just said, like, go look at the axis of symmetry for all of them? One of them broke. Okay. The very next one. Oh, no. Is it possible I parsed wrong? How could I? Where could the new line be? I've turned everything into... This is just absolutely impossible to read because it doesn't have the line breaks. But I guess the first one ends here, where I have an open double brace and a double closed brace as well. Is it possible that there is no axis of symmetry? Is that actually intended by the problem, maybe? Let's see. Ah, oops, don't resize the window. The second pattern reflects across a horizontal line instead. I see. So there is no vertical line there. It's not that there's a vertical and a horizontal axis in each puzzle, which I somehow came to believe. Rather, we have to search for the right one. So... could I then say axis of symmetry transpose get the second element? Yes. So it finds the axis of symmetry when I tell it you should look for a vertical line. So the axis of symmetry function looks correct now, except that it needs to handle the possibility that there is no axis, right? So actually, we kind of do want to do this, right? I think head still makes sense, right? We just need to say case split out x's of, if it's this, then let all this stuff and in, I guess. Oh, I don't know. We'll just do let this guard that, and there you go. Otherwise, pure nothing. We have gotten to the end of the list, and there's no answer. Pure of I. This shouldn't use a monad transformer for just this. I don't think so. So if we reload now, and say, yeah, it returns just 5 in that case. And it gives us a bunch of justs and nothings, right? Sure. No longer crashes. Perfect. And, by the way, no compiler errors anymore, or warnings, I should say, because we no longer have incomplete patterns. We're handling the result by returning nothing. And I probably don't need this for all A anymore because I'm not using that scope type variable for type annotations inside the function. So, fine. I want, I think, to write part 1 now. Part 1 of Pats, returning int, is some map. Well, it's go Pats, I guess, plus 100 times go of transpose Pats, where go is sum.map maybe axis of symmetry, I think. Doesn't quite type check. I need transpose, sure. Now it type checks. So actually, I need to, which of these am I actually supposed to multiply by 100? Number of columns to the left of each vertical line. So that's actually the ones we're transposing. We need to multiply those by 1 and multiply the others by 100. So like that. Go Pats multiply by 100. Go transpose Pats multiplied by just 1, right? Yeah. That makes sense. Let's try running it. Oops. It's a number. I mean, we kind of knew it would be, right? Because I didn't use any unsafe functions that I can think of. Well, okay, read file could fail, but we know it won't. The number might have been 0 if this, like... No, okay, this from maybe error, that's an unsafe function. If we had failed to parse the input, we would have had an error. But all of this stuff is safe. It couldn't really throw an error. It had to result in some number. Anyway, here's our number. Is it right? Summarizing your notes. To summarize your notes, column to the left. Yeah, that looks right. It's too low. Too low. How dare you? I feel like, given that I found all the axes of symmetry, well, okay, here's I guess something we could do. We could have a single function that runs over the entire input that tries to solve and multiply by 100, and if that fails, yeah, like for example, if there's some pattern that we fail to recognize as either having a vertical or horizontal axis of symmetry, that would just silently get dropped and turn into 0 the way we're writing this. Also, I guess I sort of forgot how many. There's 100 exactly. That sounds like it's probably right, but let's go check the input file. Yeah, well, that's hard to tell, isn't it? So I guess what I want to do is search for new line, please. I don't know. Is this 100? Who knows? Seems about right. Well, okay, we know for certain that we parsed the entire input file. Because our... we don't know that, though, right? We called map maybe? Nope, we called from maybe error no parse. And this never happened. So we know we parsed the whole input file, and we got 100 lines. Or 100 patterns. So, part 1, we should generate 100 ints and check that there are 100 of them. Or check that each one yields a number, I guess. Because right now I'm just saying, oh, try solving the lefts, and if you can't get it right, you know, just give it up. Throw that one away. The other side will handle it. But if one of them is wrong, then I'm throwing away... If there's one that I can't find an axis in vertically or horizontally, I'm just throwing it away, whereas that's a bug. So, let's say... do I want to let something here? Do I want to guard? How do you, like... Let's let... I want to map a function over this, and the function should be like solve each of the things and give you back nothing if you can't solve it. Map of asum, I guess. 100. Map go. Where go is asum. Now this will fail the type check because it's not returning an int anymore. Okay, fine. Let results equal map go of paths in if because go is going to return a maybe. Case filter nothing first. Second. Zip with zip 0 on results. Well, you know what? Let's just failures equal this. Failures of, if there's nothing, then return sum of map from, really I can use like from right. Map may be id, I guess, of results. And if there is error couldn't solve show I. That makes sense. So now I need to write go. Go of go is a sum of times 100 composed with axis of symmetry or axis of symmetry transpose, right? Okay. Yeah, fair enough. This was a mess. I'm not surprised it doesn't type check. What are you even upset about here? Oh, whoops. I meant to say cons to anything. ASUM is not in scope. Give it to me, please. No instance for alternative. Functions aren't alternative? I sort of thought they would be like point-wise alternative somehow. Oh, this needs to be like that? We need to reach inside the maybe and multiply it by 100? Okay, it still doesn't like that. Go pat is, it's either this of pat or it's axis of symmetry of transpose of pat. And now I don't need ASUM. I thought I could write it in terms of ASUM somehow in a higher order way. Fine, I is an int if it bothers you that much. Well, I guess I should just stack run here, right? I've already got the diagnostic information I want in the output. Hey! It's a different number. There's no error, but there's a different number. What the hell? I thought I didn't change. What I did. Oh, no. I was going to say, could there be patterns that have a vertical and horizontal axis of symmetry, and I was double counting those before, but now I'm only doing one of them? No, because my new number is bigger than my old number. Okay, well, the number I had before was too small. I have a bigger number now. I guess I can try putting it in. I don't really know what I did. Oops. It's bigger by like 300. And 21. That's the right answer. Well, I'm not sure what I fixed, sadly. I'll take it, though. You know what? Let's leave this here, I guess. We can get rid of debug trace, though. You know, it's kind of nicer, instead of using pure here, I think, to use just and lists. There you go. Hang on. Why am I using maybes at all? Okay, let's, before I start monkeying with it, first of all, confirm that small change I just made gives you the same answer. It does. Okay. So let's commit this. Yeah. Day 13, part 1. And now, head is this unsafe function. Why don't I just say list to maybe of do, and then the reason is there a reason? I need a way for this to signal failure, right? Yeah, I'm going to leave this alone, actually. So if I used list to maybe, then I could get out just like the first result. But if there's no result, I still need a way to stop, and list to maybe doesn't really give you a way to say, forget it, the list is over. At least not when just using it in do. I mean, I don't know. You could write something fancier, but this is fine. We know this list will never be empty because it goes on forever. And the first element will either be a just or a nothing. So I think that's fine. This use of head is okay. So I guess with that all committed, all right, I don't have anything left. Yeah, okay. We're ready to look at part 2. You resume walking through the Valley of Mirrors and smack, run directly into one. Hopefully nobody was watching, because that must have been pretty embarrassing. Upon closer inspection, you discover that every mirror has exactly one smudge. Exactly one dot or hash should be the opposite type. In each pattern, you'll need to locate and fix the smudge that causes a different reflection line to be valid. The old reflection line won't necessarily continue being valid after the smudge is fixed. Won't necessarily. I guess that's true. It might actually still be valid. There could be multiple answers. Oh dear. Oh, and it would be... Oh, no. So this pattern... in part 1, we looked at the first thing and saw it had a vertical line of reflection. But after fixing the smudge, it should have a horizontal line of reflection. Yeah, that makes sense. Fix the smudge and find the different line of reflection. Uh-huh. And I imagine it could be... Yeah, the second pattern previously already had a horizontal line of reflection, right? And fixing the smudge gives it a new horizontal line of reflection. So... we need, like... I mean, first of all, brute force should be good enough here, right? Just trying all the places you could smudge. I don't think you need to be smart about this. Because there's 100... 100 patterns, 1,300 lines by 50, by 20, right? So there's only, 300,000-ish places you could put a smudge. Computer should have no trouble grinding through those. Now, that might not be the best way to think about it. What if instead we just... instead of like trying, oh, I'll smudge the mirror here, then reflect it, and then see if it lines up. We could try, let's say we put a candidate mirror reflection like in between these lines here, right? And we found that it's off by exactly one character. Like, we compare the result of zipping, and we say, oh, interesting. If this here were smudged, this line would work. Everything except this one thing matches perfectly. Therefore, this is a place where you could apply a smudge. Now, is that actually better than trying all the smudges and then trying all the reflections for all the smudges? I think it is. Because we're just doing a single reflection for each pattern. Well, a single pass of the reflection function looking at each row. And then, we kind of already have to, for like part 1, we have to say, oh, are these, do these line up? And... sorry, where was I? Yeah, we kind of have to match them all up. We were using, compare, oh, they should all be equal. But we could instead say, oh, show me how many of them are equal. Or, not equal, really, right? So we could pass into the axis of reflection function an argument saying, here's how many smudges I want you to find. And if the number that you find is not that, then keep looking. If the number that you find is that, then give me the answer. Now, our current type signature for access of reflection does not allow this because there's no way to say, oh, this list is almost equal to this other list, or this A is almost equal to this other A. We don't have the level of granularity there, right? But I believe we can just do this, and everything, oops, should still type check. We've made axis of symmetry less general, but we were already passing it a type that fits its less general signature, so that's fine. So what we want is wanted errors, basically. We want to pass an int to this. So we can just change this guard all id thing to something else. Guard of equal num wanted, hello? Oh, wanted errors. Filter not. Right? This is almost right. Annoying. Like, I don't know. I guess I'm going to say, right, put a composition there. Like so. Length. Okay, so now axis of symmetry type checks. The problem is that the place we're using it in part 1 is unhappy. We'll just say match is axis of symmetry 0 smudges, please. Match. Okay. So if I stack run this, that's the same answer I gave, right? 35521, yes. Okay, so let's just commit that before I fuck anything else up. I mean, I don't know why. Let's define a function solve. Takes an int and gives you back a function from input to int. Solve num wanted solve smudges is solve smudges and paths is this. Where match is axis of symmetry smudges, right? Part 1 is just solve 0. Part 2 is solve 1. Yeah? Type checks. Let's run it and make sure that we still get the right answer for part 1. And if we do, the answer for part 2 is probably right. Exactly 19,000? That's a little bit suspicious. But I think it's right. We checked that we solved each of them. We haven't changed how we're doing the multiplications. I think that's probably the right answer. Too low, too low. Okay. Summarizing the new reflection line. Summarize your notes as before. Yeah, so this still makes sense. Horizontal lines still get multiplied by 100. Vertical lines still don't. So my belief was that so I guess something must be wrong with axis of symmetry. It makes sense that it still works for part 1, even if it might not be handling wanted errors right, because, you know, this is basically just a weird way to say the lists are equal. Oh! Hang on. I think the problem is, yes, I didn't make use of the fact that I have this list of A anymore. Right? I'm just comparing the rows of the input, or the columns, and saying, oh, these 2 rows don't match. But if I smudged this entire row so that it matched that other row perfectly, I'd have an answer. Okay. So I need to do a more complicated zip with, where I take, like, the elements of I take each row and zip it with its counterpart. And if the number of errors in exactly one row is exactly 1, then I have the right answer. Okay. So that makes sense. So we need to write a function called errors, which takes 2 lists of A and finds places where they don't match, zipping them with each other. Now, shouldn't the zip list applicative help here? Maybe. Maybe you just write zip with twice and get on with your life. Where I mean, I guess I could put it there, right? I don't. I thought I wanted it to like here, but I guess I didn't. Or to here or something? Like, is this not? Okay, yeah. Errors equal undefined. Undead? Where did you find that completion from? LSP log. Okay. Undefined. Oops. This is supposed to be $, and this is supposed to be nothing. Yeah. So now you're saying, oh, you don't need eek anymore because errors just works by magic and wishing. and fairy dust. So where are the places I can legally put this? Pretty much anywhere I want, right? I kind of want it here, but it's not one of the places that the indenter suggests. This is also fine, I guess. But I like this better? I don't know. I don't know Haskell style. Apparently this is what you're supposed to do. If that's what the indenter says, it's probably right. Errors of A's, B's is... I need to zip A's and B's together. I guess it's like the sum of zip with well, actually, I have a list of rows. 2 lists of rows. Row errors where row errors is sum zip width equal? Not equal. Does that make sense? Parse error. How dare you? Surely that's not right, is it? Apparently it is. Oh yeah, you can't just... Yeah, you can't just... Okay. Is that what I wanted? No. Okay, forget it. I'm out of point free land. A's, B's, here we go, is the sum of zip width row errors, A's, B's. And this is row errors, A's, B's is the sum of zip width not equal A's, B's. Okay, it's the same type of error I had before, which means I probably was right with the point-free approach. But the function is still wrong. In what way? Oh. Actually, that's yeah, of course. I'm trying to sum up I have booleans and I want to treat true as 1 and false as 0 or something like that, but I've zipped the lists together. And now I have a list of bools. And I guess I want the length of filter not. All right, that compiles, I guess. That's a much more promising number because it's actually close to our... Like, there's no real reason to suppose that this should be larger or smaller than our existing number. It's just a different line of reflection, right? So it should be close, and it is. It's the right answer. Okay. So let's get commit this first. Day 13 part 2. And then I want to go back to what I had a minute ago, which was... Yeah, that's right. Oops, should be a dot here. The operator, interesting. Okay. I mean, I don't know. Is this really prettier? Cleaner? It kind of makes sense, right? Like, you don't need to mention A's and B's. We're just working with function composition, and, like, the way you compose two-argument functions is a little obscure because, from Haskell's point of view, every function is a one-argument function that just returns another function. So if you want to, like, take two arguments and then call f and then call g, you can't just compose f with g, because that would take one argument, call f, yielding a function, then call g, and that would be applied to the second argument, kind of, or something like that. So what you do is you say, okay, zip with row errors is a function of two arguments. We know that. It takes like A's and B's. I want to compose that with, not with sum, but with the function compose with sum. And like, you can do the type arithmetic there and find out that it happens to actually work. And in the same way here, I have, you know, a function of one argument to compose with zip with equal the function of two arguments. So we say compose zip with a function which is composing the composition of length and filter not. I mean, this, I don't know. Is it pretty? Sort of. Now, somewhere, where is it? There's a function, dot colon, I think is a typical name for this. Where is this? Does it exist in any, like... It doesn't really exist in any base modules. Pointless fun. Okay, yeah, that's true. So colon dot takes a two-argument function from A to B to C, and a single-argument function, C to D, and composes those together, giving you a function from A to B to D, which is what we want, right? And all these uses of dot equal, or dot colon, is like... Well, not all of them. Some of them are this composition, I think. Maybe not. Most of these are in, like, ASON, the JSON parsing library, huh? Here's one from, you know, the one-liner function or library. I don't remember what opali is. Anyway, the point is we don't want any of these. But data.composition, same thing. You know, we could depend on that if we really wanted to, but I don't think it's a particularly good idea. But this is... You could write this function once, and I guess we'll do that as a little exercise here. Day 13.3 for fun. And then we can say even like colon dot is compose with compose, which, you know, oops, dot colon. We don't have to, actually, you know what we could do is we could put it right here. And then we could just say sum compose with zip with, and this compose with zip with. Like, you know, that's cute. Certainly, I think makes these a little bit less inscrutable, the definitions for errors and row errors. This, of course, is inscrutable if you've never seen it before, even more, I think, than what I had written before. But this is just sort of like, you know, it's in the textbooks or the meme universe or something, as like, I just know this is the way to define a function that composes a 2-argument function with a 1-argument function. I've seen it a million times. I know this is a definition that works. Funnily enough, you can even write fmap, 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 and that also works, I thought. Why not? I thought that worked. Huh. I thought the reason that it worked is that compose, the compose function, is fmap when viewed in the function monad. Function applicative. Function functor in this case, I guess. That's weird. Oh, did it... What type did it infer? Because it might be inferring... Yeah, wait, hang on. Type wildcard. I don't know, this looks okay. A1 to B. Yeah, that actually looks right. I thought it might be inferring a monomorphic type because it doesn't look like a function definition. Couldn't match type A with list of A. Weird. Anyway, this is just a little toy. I don't totally understand why it's wrong, so... So we'll like, I guess, commit it like this, because why not? I feel like, though, these really ought to be in a branch where, like, the canonical solution is one that looks a little bit less ridiculous. Whatever, it's fine. Day 13, using, capital using. Okay, that seems like enough for today. I was pleased with the fairly small change, I would say, to part 2, where I realized you don't need to search through all the mirrors and try all the places to put a smudge. You can just try all the ways to reflect the mirrors, which we're doing anyway, and then count up how many smudges would be needed to make this work. And if the answer isn't 1, then it's not the new line of reflection. Cool. Hope you guys enjoyed. Thanks for watching, and I'll see you next time.